Alright, so this video is going to cover the 2012 free response question number 4, gray image. So let's go through. It says a gray image is represented by a two-dimensional rectangular array of pixels. A pixel is an integer value that represents a shade of gray. In this question, let's see here. In this question, pixel values can be in the range of 0 through 255 inclusive. A black pixel is represented by 0 and a white is 255. So we got this gray image class where we have black is a final variable and it's 0, and white is a final variable that's 255. And then we got a two-dimensional array called pixel values. We're going to count the pixels in part A and we're going to process the image in part B. So write the method count white pixels that returns the number of pixels in the image that contain the value white. Okay, so let's think about this. White is equal to 255, so we would have 1, 2, 3, 4, 5, and so it would return 5. Okay. So you would write this here. So think about this. You got a 2D array. You got to do the rows first and then the columns next. So and then you're returning what? Returning your, what's the variable? Write the method, for example, soon. I guess we'll just create a variable ourselves. We'll just call it white pixel count. So, what do we got here? Int white pixel count is equal to 0, and since we're going to return it, so we'll say white pixel count. Okay. Now, there's a couple ways to do this. I'll show you both. Okay, the first way is just the traditional way. We've got our for loops. So if I have int row equals 0, row is less than the pixel values dot length, that's our 2D array. That's the row section, row plus plus. Then inside here we have int call. Call is going to be less than the pixel values at row 0. And that just gives you the number of, that just gives you the columns in row 0, and since they're all the same number of columns, you can just do row 0. So this is pretty easy. So if our pixel values at row column is equal to white, then we white pixel count plus plus. So all we're doing is just going through each cell here. Whoops, wrong one. Each cell here, one at a time, by row. Boom, boom. 255, 184, 177. Okay, and each time it sees 255, it just adds 1 to it. Okay, so that's pretty easy. Here's the alternative way to do it. Okay, and this is probably what they want you to see at, AP, is they want to see a for each loops. So it would look something like this. So we would say for int at row, and we're looking at the this dot pixel values, so that would give us our row, and then int call is a column in the row that you're in. Okay, then we just do if column is equal to this dot white, and then we've got our, okay, pretty easy. That one's pretty easy. Let's go to the process array now. All right, so the process image, now we can read through this. All it's doing is it's going to process the image. Let's read this. Well, maybe we should read it. Write the method process image that modifies the image by changing the values in the instance variable pixel values according to the following description. The pixels in the image are processed one at a time in row major order. Row major order processes the first row in the array from left to right, and then processes the second row from left to right. Continue until all rows are processed from left to right. The first index of pixel values represents the row number, and the second index represents the column number. Okay, so the pixel value at row column is decreased by the value at positions row plus 2, column plus 2. So look at this. This would be decreased by row plus 2, so 1, 2, 1, 2. So 221 would be decreased by 0. So 221 minus 0 is 221, which you see right here, okay? 184, then you go down 1, 2, 3, 4 right here. 184 decreased by 0 is 184 right here, okay? But then this is where we get to 178. You know, you go 1, 2, and then 1, 2. 178 is decreased by 78, so that should be 100, which it is right here, okay? Now, this one right here, down 1, 2, 1, and then 2, the fifth column doesn't exist, so this stuff right here and these ones, because think about it, you go down 1, 2, or sorry, from here you go down 1, and nothing exists. So these are the only pixels in this two-dimensional array that can actually be changed, okay, and that's why they're bolded and kind of a bit more black, okay. Now we are missing something else. If the result of the subtraction, excuse me, I'm going to sneeze. Excuse me. If the result of the subtraction is less than the value black, now what's value? What's black? Black is 0. So if we subtract it and we get a negative number, if it's less than 0 black, the pixel is assigned the value of black, so it's assigned to 0. So look at this. So 84, if we go down 1, 2, and then over 1, 2, 84 minus 255 is a negative number, so this gets assigned to 0 right here, okay? So the biggest thing here is not to get an index out of bounds there, because if you start trying to subtract something that doesn't exist either over here or down here, you're going to have issues and you have index out of bounds. So that's what you really have to watch for in this one, okay? So let's process this image. Okay, so alright, so let's see here. So we're just going to do, I'm going to grab this code right here. Okay, because it's the same thing. You're going from row 0, you know, and then column row 0 to the end of the length of your rows, and then column 0 to the length of your columns, okay? So in here, we're going to say this. Oop, no, wait, now I've got issues, because remember what I said with not having an index out of bounds here on the columns or the rows. So you need to make sure that the length is -2 on both of these, okay? So we only process 2 row to row 0 and 1. We went process to this because let's see here. For rows, this would return, sorry, this one would return 4 minus 2 is 2. So we don't want to process to row 2, we want to process less than 2. So 0 and 1 are both less than 2. And same thing over here. This would be, the length is 5, 5 minus 2 is 3. We want to process all columns less than 3. So 0, 1, and 2 are less than 3. So that takes care of our index out of bounds errors. So then we just do this dot pixel values at the row column minus equals this dot pixel values row plus 2 call plus 2. Okay, now that doesn't that does that, but it also creates the negative numbers which we don't want. So then we got to check to see if this dot pixel values at your row and your column, if those are less than our black variable, then this dot pixel values row call is equal to black. That should, so this takes care of no index out of bounds. We subtract you know, the original one minus whatever the row plus 2 column plus 2 is. If this now is less than 0, then we assign it to 0, okay? So let me think here. That should be good. So this is a really kind of easy two-dimensional array problem. So and I'll post this you know, free response question, because what happens is I've got the canonical, they call it canonical or rubric, where they show you where all your points are added for each part, and I think the answers are down here too. Yeah, they are. Okay, cool. So this video is done.